Background of study. In Malaysia, approximately 1.2 million ton of agricultural waste is produced every year. These agricultural waste can be used for BAC for many purposes. One of the purposes are these agricultural waste can be converted into an activated carbon, which can be used as an adsorbent and also can be converted into bioenzyme. These biomass activated carbon and bioenzyme can be an alternative to commercially available activated carbon and oil adsorbent pads, which are chemically synthesized. Moreover, the biomass activated carbon contains cellulose. Cellulose is the main substance found in plant cell walls and helps the plant to remain stiff and strong. Cellulose is a substance that plays a main role in the adsorption process. Our team has used three types of agricultural waste to produce biomass activated carbon and bioenzyme, such as banana peel, sugarcane bagasse, and coconut husk. Furthermore, BAC bioenzyme is an excellent adsorbent for oil and wastewater or industrial wastewater treatment because they are low cost, environmental friendly, abundantly available, efficient for various pollutant removals, and has problem statement. Oil spill accidents often take place during the oil utilization process, resulting in energy loss as well as threats to the environment. It is important that after an oil spill, the marine cleanup operation should collect or adsorb quickly a major part of the oil spill, especially in coastal areas. Oil polluted water often contains other substances as well as oil. Therefore, the existing cleaning process are complex and may consist of. Our aim is to develop a biomass activated carbon integrated with bioenzyme for the removal of oil from wastewater using agricultural waste as known as coconut husk, sugarcane bagasse, and banana peel. Our research objectives are to prepare three types of biomass activated carbon integrated with bioenzyme from three different wastes, namely sugarcane bagasse, coconut husk, and banana peel, and to investigate the potential of newly developed BAC bioenzyme powder on removal of oil from wastewater. Biomass activated carbon. The materials that are used for developing biomass activated carbon are sugarcane bagasse, coconut husk, and banana peel. First, we should wash these three samples with clean water. Then the samples are dried under the sun for about 1 day. The samples are dried again in an oven for 150 degrees Celsius for 25 minutes to remove excess moisture from them. The dried samples are crushed into powder. The powder is called biomass activated carbon. Preparation of bioenzyme. The materials that have been used to develop bioenzyme are sugarcane bagasse, coconut husk, and banana peel. These samples are put together with water and jaggery into a plastic container with the ratio of 15 to 10 to 3 to 1. The lid of the container is opened and closed every day to release the methane gas that is produced from the mixture. This process is repeated for 30 days. After 30 days, the mixture will be kept in an airtight container.
Adsorption study. Adsorption study is done to find out the percentage of oil absorbed by BAC biomass powder. First of all, we need to add 10 ml of crude oil with water. We use crude oil because it is widely spilled by the industry into the ocean. Then we need to add predetermined of BAC biomass powder with the solution. Then we need to transfer the mixture to the shaker. Lastly, we need to filter the mixture and the product will be analyzed in UV spectrometer. Experimental condition. The volume of oil that we use is 10 ml. There are 4 operating conditions that we use. First, adsorbent dosage. Parameters for adsorbent dosage are 40 mg, 80 mg and 120 mg. Second operating condition is contact time. The parameter for contact time is 50 minutes, 150 minutes, 800 minutes and 720 minutes, that is 12 hours. The type of oil that we use is crude oil and the concentration of the oil is 50 mg per liter. Result and discussion. These are the results that we got from the FTRI analysis. Based on the FTRI result, we can why banana peel BAC bioenzyme has more potential to absorb oil. These three images are the result that we got from the SEM analysis. Based on these images, we can find out that banana peel has more porous structure than the coconut husk and sugarcane bagasse. This shows that banana peel has more potential to absorb oil. What's the function of porous structure? Porous structure helps the process of absorption. The more the porous structure, the more the oil absorbed, or the more the porous structure, the faster the oil absorbed. We have done an absorption study with two different operating conditions, which are the effect of contact time and the effect of adsorbent dosage, to find out the percentage of oil removal. Now we are looking at the effect of contact time. Based on the graph on the right hand side, we can find out that oil removal percentage for banana peel is 76.6% and sugarcane bagasse 33.2%, are highest at 150 minutes, while for coconut are 64.8% oil removed at 720 minutes, which is 12 hours. Based on this, we can find out that banana peel is more effective because it absorbs oil in a less amount of duration. Now we are looking at the effect of adsorbent dosage. Based on the graph on the right hand side, we can find out oil removal percentage for banana peel 76.6% and sugarcane bagasse 33.2% is highest using 83 mg of adsorbent dosage, while for coconut husk 64.8% oil removed by using 120 mg adsorbent dosage. Based on these, we can find out that banana peel is more effective because it absorbs oil with a less amount of adsorbent dosage, which is 80 mg. There are some reasons why we chose agriculture waste to develop BAC bioenzyme powder. In Malaysia, agriculture waste such as banana peel, coconut husk and sugarcane bagasse are abundantly available and can be obtained at low cost. Besides that, these agriculture waste won't cause any pollution because it is natural resources, biodegradable and eco-friendly. Moreover, this agriculture waste has more potential to absorb oil than the other agriculture waste. Commercial application. As for commercialization, BAC bioenzyme can be commercialized to the industry as they are the one who spilling the oil into the ocean and causes pollutant and extinction of aquatic animals. This BAC bioenzyme can be also commercialized to the people for domestic spillage. Conclusion: BAC bioenzyme powder was successfully developed by using sugarcane bagasse, coconut husk and banana peel. All the three BAC bioenzyme was synthesized without chemical modification, able to remove oil from wastewater. The banana peel was found the most efficient BAC bioenzyme powder.
Firstly, the materials that we need are biomass activated carbon, bioenzyme and a sponge that is cut into cubes. After preparing the materials, I am going to mix the banana peel biomass activated carbon and bioenzyme together. Then I will let the sponge that was cut into cubes to soak into the mixture for a while. After it has soaked for a while, I will leave it to dry under the sun. These are the BAC bioenzyme cubes that has already dried under the sun. In this video, I am going to demonstrate that BAC bioenzyme powder can absorb crude oil from water. Firstly, I have filled water in a flat bottom flask. Now, I am going to pour 10 ml of crude oil in it. Then I am going to put the BSc bioenzyme powder in it and stir it for a while. Now I am going to filter it. Thank you. As you can see that the BSc bioenzyme powder has absorbed the crude oil in the water and made the water clear. As conclusion, BSc bioenzyme powder was successfully developed using sugarcane bagasse, coconut husk and banana peel. Therefore, we can prove that BSc bioenzyme powder developed from biomass, have great potential to be alternative to commercial adsorbents for oil removal in wastewater. Thank you.